Hi, everyone. Welcome. First of all, let me congratulate Poland with a recent win over Germany in football. I'm a Brazilian, and some of you might remember a recent encounter. I still wake up crying at night, thinking the game is not over, and it's 14-1 now. So yeah, sorry, but congrats. Okay, today we're talking about enforcing architecture pattern with static code analysis. And what that means, this is not any groundbreaking news. This has been around for a while, and it's just kind of pointing out the importance of doing this and the fact that time and time again, we see that teams don't take advantage of these tools that are available to doing this kind of work using static code analysis, which for the most time, it's pretty powerful. So, all right, before we start, the points and expression, the overall ideas here, they're my own. They don't represent necessarily the ideas of my employer, just the legal stuff. I'm a Java guy. I've been doing Java since the beginning. Before there was a web implementation doing applets and all kinds of good stuff. More recently, just doing web development. I'm part of the Oracle Taleo group within Oracle. I've been with Taleo since 2010, and in the last couple of years, Oracle acquired Taleo, so it kind of became Oracle by osmosis here as they continue their work domination through acquisitions. Today, I have one copy of the Lean Architecture group to give away, so if you ask questions, and you might get one. This is a pretty interesting book that kind of covers some of the points that we're going to talk about here, but also covers how architecture should be rolled out as we move into agile processes. So not only on the architecture itself, on the code, but also in the people and processes and the different teams that interact in the agile process. So, all right. So we have a few things to cover here. Initially kind of setting up the reason why do we need this. We're all suffering from architectural decay. The solution here is to go and do this architecture agility, and this is a term that has been coined by some of the folks from Carnegie Mellon that really identify what are the ways that we can prevent that architecture decay, and it's through doing a more formal, a more integrated way of defining the relationships of your application, your modules, your packages, and defining and making that work into your code base. And if you guys have questions, just raise your hand, and we can kind of go from there. So anyone here, so who is using static code analysis here at a daily basis without, not including your IDE, just a formal package, formal applications? All right, a few folks. People using find bugs? Okay, and people using a formal kind of a architectural SCA, okay? Okay, cool, it's good to know. We go quickly through these first levels, and we're gonna do a demo later on, kind of setting up some layers and doing some formal exercise. So just set the ground here. What is architecture? This is kind of the overall rule, and what we're thinking about here is really the relationships between these artifacts in your application. You have different modules, you have libraries, and over time, these relationships change, right? And over time, those relationships between your modules, they become less apparent for your new guys, for just the complexities, the stresses of the overall development. Things just start kind of degenerating. The key point here is that over time, as you grow your systems, there's work that needs to be done to enforce that you basically not increasing the complexity of the system. And complexity has a bunch of side effects, which can be devastating. Your ability to kind of make improvements to your system quickly, it becomes a much more expensive task in some cases if you don't really keep a track on that. So I thought this cartoon was pretty interesting. Basically, I mean, from a user perspective, we have one button that does your job, but people don't realize what is kind of behind that. And over time, that mess that is kind of behind our applications just become really out of control if we don't keep a close eye on it. So overall, it's really just how things become more complex. Systems just grow naturally. The complexity go up. The architecture is not documented. The developers don't know or understand their architecture. A lot of times, some of these frameworks like Spring and some other MVC-based frameworks, they really helped kind of best practices, implement the best practices, and new developers come in, they're already familiar with that framework. Chances are they're going to do the right thing, but there's just so much that goes beyond that is specific to your application that people just tend to overlook, right? Overall, kind of people taking shortcuts in overall development processes, and when you kind of working on different teams, right? Working in dispersed teams, basically what happens is certain teams, they make certain decisions that didn't get communicated through the rest of the organization. And what happens is we start kind of having different parallel decisions happening to the same aspect. So we want to avoid that as much as possible. All right. So then it comes the term of architecture, agility, and what that really means is it's really the ability of having architecture be part of your Agile process, right? And it's really understanding the fact that you just need, for every story that you're going through, for when you're looking at the stories and the fact that architecture should come up from the business value they're introducing through your stories, what are the things that we need to kind of be thinking ahead of actually working on that specific story? So having the dependency analysis in place for your application can go a long way. So when you look at a specific story and you're estimating that, you're making a judgment call to say, okay, what are the things that are going to be impacted by this, right? What are the things that this depends on, and what are the things that depends on this? And having the visibility can really help not only estimate the effort of the task, but also for QA, for quality analysis, and a number of other things. Real option analysis. This really comes out from investigating, okay, do I have to do this architectural work now versus later, right? And having the ability of being aware of this, that's kind of the key value here. So you always want to delay that if you can, but then having the visibility, I guess that's the key point of this. And technical debt management, it's understanding what is your technical debt and basically dealing with that. So when you actually going back in the code and making enhancements, what are your real, should you take a stab of your technical problems there that are already part of your system? So this is an interesting article, this enabling agility through architecture. This kind of covers a lot of these aspects that really enforces the fact that there's a real problem here, and the solution is by keeping an automated and an integrated way of dealing with these architecture decisions that were made, and over time they get lost. All right. So here, for example, it's kind of a diagram. This is the Spring 3.0 module dependency. This provides a lot of information. This is kind of the core aspect of creating what can depend on what, right, and what does not depend on what. For example, here if I'm making a change to any of these components of the Spring framework, I have a true understanding of what are the dependencies on that and what can I possibly be breaking. So getting that constant view of what you're doing and what are the different changes here, they kind of go a long way. For example, just for example here, if I'm making a change here to the ORM component at the bottom, chances are the repercussions of making a bad move here are very limited versus changing something on the core that is kind of used throughout. So that's kind of the key point here. All right, and technical debt management, again, it's whenever you're refactoring your application, and when you need to refactor within the unit code, within the unit of code, that's usually tends to go pretty well. Whenever you start refactoring the relationships between your modules, that is very expensive. So the sooner you have visibility that you're breaking a certain condition of integration between your components, that's where you want to have visibility early and soon. And also, over time, as you get problems in your dependencies and the relationships of your components, your ability of creating, making changes, and adding features to your system, they start getting harder and harder. That's to the point that is basically require a rewrite of some sort of going back and rethinking how those connection points take place. All right, so now we're kind of start defining some of these things. So how do we go about defining these relationships in your application? And at least the first thing is really defining what you want to get out of it. And then the second part is enforcing that. So think about your application as a multi-layered, for this is example here, like we have a cake with different layers of goodness, and they all kind of have different tastes and different functions. So your horizontal slices are going to be your different layers. And I think we're all familiar with that. We have our controllers or services, and could be any number of layers that is really up to all of us to do. And how the different layers interact, it's not really up to us how to do it too. And like I said, there are certain standards in place that kind of help us do that, that for the most part has been proven to work well. And but basically, I mean, it's really up to us to define. And the key of the matter is, over time, we want to keep that same relationship between those layers. So how can they interact, and also how they cannot interact? This is a crucial point. The other one is your modules, right? So whenever you create your application, you want to define what are kind of the functional modules and the different parts of the application. So they potentially can implement those same layers across the board, the same layers the same horizontal layers, but then at a vertical perspective, okay, this is my cart feature versus my catalog feature, my ordering feature, and so forth. And then again, define those vertical relationships are pretty important, right? So in that case, then you can really segment your application in a way that you can deploy, for example, upgrading your version of your catalog and still making sure that you don't have to retest your entire application. Because if you understand that dependency, you can upgrade a new version of your catalog, go to version 2.0, and still having being backwards compatible with other versions of the application. All right, so a little bit more in layers. Basically, Java is really great for defining the package structure, the hierarchical package instruction in Java. It goes really long way, kind of help us define that. I think a lot of people don't really give the proper thought of how they define their packages in the application. But basically, that's what it's made for. So use that, take advantage of that, and be very smart on how you use that. The layers of the same module are really built together. So try to build your specific layers together and bundle them as a module in your application. And again, use the jarring and the packaging appropriately for your product. And this one it's kind of interesting. Whenever we start building these things. It's very easy for us to be able to kind of look up a static variable somewhere that is not available to us, and just the importing is very forgiving because the compiler doesn't care. The compiler just allows you to do those things. So how do we prevent today creating those dependencies between the libraries? So anyone applying any specific ruling? So in terms of how can you keep track that there's new dependencies are not being introduced between layers that you kind of have defined? Any thoughts of people practicing that the policy of not allowing and managing those relationships? Right, and how do you do that? I mean, okay, perfect. So yeah, so that's the thing. I mean, we want to keep an eye on defining what is possible and preventing that in an ongoing basis. So your modules, we kind of cover that a little bit. So there are a few options here of how you create your modules. OSGI, it really does a good job in kind of defining what a module is, what is the version of that module, what's the compatibility levels of that module, and allows you to kind of have a very modular application in your system. And basically, again, OSGI is really kind of a glorified jar. So jar is a really good way. And if not possible, also you can also do it at your package level, right? So even if you have one big application, whenever you're creating your package hierarchy, keep then this differentiation about the modules and the packages in mind. again, how do we prevent introducing these unwanted dependencies between the modules is kind of a key question here to keep in track. All right. Okay, so whenever you're thinking about packages, right, you want to be able to slice and dice them. You want to have a convention that what you want to do is in terms of the hierarchy and how deep you are. And you want to kind of think a little bit about where do you think your product going, and if you already have an existing product, I mean, how can you revisit some of these things so that you can really take advantage of these this hierarchy. So there's a couple ways here. One is the package by feature, and another versus the package by layer. So the package by feature means that, and I think I have a couple examples here. So when you think about feature, you want to have your product and then have your module first. And the module might mean it's something that is specific to your application. It's a piece of functionality. And then you have your layers down there. If you start with your layers first, then things can get a little messy. And there's some pros and cons with the two approaches, but people tend to convert that if you start with your logical and your domain-specific layers higher up in the hierarchy, you'll be better off because the layers down below, they tend to repeat themselves over and over. So let's take a quick look here how these two do compare. Let me see if I switch here to my Eclipse. So I've set up a quick project just for the sake of the example here. And this might be hard to see. So let me see here. So is that a little better? OK. So I have these three applications, right? And they were packaged a little bit different, each one of them. All of them, they depend on my common DAO, right? The first application, right off the bat, I see that they're multi-layered application. I see a DAO, I see a model and a service here. But at this point, I still don't know anything about what this application does. So let's keep going deeper. So now in my DAO, I know I have a couple of tables, most likely a buyer and an order. And I can also have a similar thing for representing those models, a buyer bean and a buyer DAO. And for my services, OK, all right. So I know that at this point, I have an application that has something to do with taking orders and handling buyers, right? And what I'm seeing here is that I had to go pretty deep to kind of understand that. And let's say that if I want to get rid of if I want to get rid of buyer, for example, altogether, I need to kind of traverse my tree and kind of look in all the different places and all different layers to kind of get rid of that. So yeah, so I see that I have quite a bit of packages here, and it's not very modular from a feature perspective, so to speak. So if we look at the second example here, I have a module first type of example, and here I can see right off the bat that I have a buyer and order, so I get a little bit of information about what the application is about. I go in and I say, oh, okay, I have a DAO, a service, and the buyer object, which is just my model. And here's a little better. It seems like everything is kind of closer together. I don't have to go too deep. I don't have to kind of extend and contract too much. They're kind of pretty tied together. If I want to get rid of buyer, I can just delete this guy, and should be pretty harmless. One thing here is that I don't understand how the buyer, the DAO, and servers, they really relate to each other. And I'm kind of limited because they're not compartmentalized here. So another approach here is, again, doing module first, and then for each one of my modules, have different packages that represent these different things. So this is kind of cool because now I can, if I know that, for example, my common DAO is my base class for my DAO, for example, here, I can tell that only my DAO package can have a dependency on my common DAO, right? Here on application 2, I couldn't do that. I couldn't just say, OK, I guess I could. I could say that order could depend on DAO, but then I'm not specific enough about order service or some other classes that are kind of depending on that. So this kind of shows a little bit of the point here is that The more granular you go, and you don't want to go, you have to find your certain level, the right level of granularity is how deep you go and kind of how you organize these things. So any questions or comments to this? Yep.
Which approach is the best for you, for your cases?
In my case, would be the three, which would be module first, because it kind of defines the boundaries of each one of my features, and then the different layers. And as long as you name the layers that they're the same thing across the different modules, then in your static code analysis, you can really kind of dial that in. So, but again, I mean, I think that there's pros and cons depending on what you're doing. But the point is that this shows this is a little bit promising to kind of how this is implemented in the app 3 option. Okay, how do I get rid of this? All right, so I think I can come back now. Okay. So, all right, so now we kind of talked, we kind of defined how we want those layers and those modules to be in place. How do we go about actually enforcing it? So I'm a little bit more in static code analysis, right? It's very cheap. Whenever you have something in place, it's very cheap and it's very efficient to find certain types of bugs. This is not meant to replace code reviews, but then it's really good at finding some stuff that code review is really struggling on finding, right? So there's quite a bit of tools out there that do a really good job in finding things at the unit level or the certain relationships. Not so much at the architecture level, right? Those are not as common, but they do exist. They reduce the need of knowledge of large frameworks, and that means by relying on these automated tools, these automated checkings, you kind of might be, you can put rules in place to prevent certain relationships that are not allowed, basically. They do allow for exceptions, meaning that differently than the compiler either can do it or you cannot do it. You can configure your static code analysis to say, oh, this is an error I understand, but I'm going to take this one and I'm just going to ignore it, right? Which in the compiler, when there's an error, there's no way around it. You just need to fix it. And again, it's just good around enforcing best practices, avoiding code smells, and those type of things. And being automated, I think that's kind of the key point here is that you want to use that as part of your build system, as part of your compilation almost at the IDE level if possible. So yeah, I think we covered that. So looking at the big picture, right, of what static code analysis should be. So the compiler is really a static code analyzer, right, that is doing all this stuff. It's not running any code. That means it's looking at generating bytecode, looking at your bytecode, make sure that all those relationships, they check out. And one of the premises whenever Java was created was that it's going to be architecture agnostic. So it's not going to impose any architecture on anyone. But then over time, we found that people were, failed to do certain things in a proper manner. So some of these frameworks, struts in Spring and all these kind of frameworks come up to provide a little bit of that architecture support. But it is still very agnostic of your own application, right? So there's quite a bit of work that is left out there, and most people don't actually document that and make that part of the process. So the idea is that why don't we enhance our build system, our compiler, with this extra information that is specific to us, that we feel it's important, and it should be part of, and we should not break those rules. And today, time and time again, we're just choosing to ignore that and not spending the proper time. So I guess the call here is that someone needs to hold the key of defining those and making sure that if they need to be changed, a conversation needs to be done to be had instead of just ignoring those things. So most common use of SCA that we see across the board is find bugs because it's easy, I guess, and because it's awesome. Find bugs, it's free. Can just plug it in. It finds a lot of good stuff. Very effective in finding bugs and code smells. It doesn't really deal with the problem that we're talking about here, about the dependencies and relationships and things like that. There's quite a bit of SCA being done for security vulnerability too. and doing the SQL injections and things like that. I mean, all that stuff is very, very related to SCA can help. Unit test coverage, it's another one. And there's quite a bit of tools out there. So all of our modern IDEs, they include quite a bit of support around SCA for little things and sometimes big things. Find bugs, most common. Coverity, it's one that is a commercial level that has been getting very good traction. We use Coverity internally, and what we see is that a lot of there's less false positives than a lot of other tools there. So the actual, whenever they raise issues, those are actual issues that you want to pay attention to, versus some other tools that basically just list a bunch of stuff there that they might not be ideal to have, but I mean it's okay. They're not going to cause you a problem, basically. And at the end of the day, you need to kind of prioritize those, and there's just so much time to go back and kind of correct those things, so that's kind of the point. There's a couple dependency analyzers there that we used before, Dependency Finder, JDepend. Some of those are very basic, haven't been supported for a while. And some of the tools that are commercial level and more architecture focused is, for example, SonarGraph, and that's kind of the old SonarJ. Anyone using SonarJ or SonarGraph? All right, cool. And Lattice and Structure 101. So those are the ones that really allow you to kind of define these relationships and kind of do the work that we're talking about here. So all right, so let's kind of go back to the application again. So I picked up a very tiny multi-layered application. This is the Spring Pet Clinic example. And I found this slide here that kind of shows, okay, this is a layered application. I have a DAO level, a service controller, and the views. And this is the kind of one that, it would be kind of interesting to kind of look. So, so let's see how we would go about kind of defining some of that. So let's go here, and this is, I'm going to be using SonarGraph here. I'm going to create a new system. And I'm going to say Pet Clinic. And I'm just going to import, it's a Maven build. It seems like it's already there. I don't want to import the transitive guys. Okay, found that. Yes. Okay, so what this did, it imported the application. It did probably, let's see, did it find the code base? So I have, it looks like I have some issues here in this application, right? So this is kind of the dashboard. The architecture here, it says that it doesn't violate anything because I've just imported. I haven't defined my layers or anything about that yet. So basically, it's all green because say, no, you never define anything. There are 46 files in this project, and 46, it's 100% of them, they are not mapped to any architecture paradigm because we just started those. It looks like it found a cycle here. Let's take a look at that, which is not good. They all show green because they don't know which relationships are allowed and not allowed. So that's what we're going to do. So let's go ahead, and this is kind of the logical view of how do you define your layers. If we expand it here and we look at the different packages that we have, actually they package it pretty nicely, right? So we have a service layer. Let's go ahead and create a vertical slice group here, meaning that this is one of my layers, not one module. So I'm going to just create a service model, and oops, I actually selected the wrong one. I'm going to select a vertical layer group. Okay. And then I would go ahead and do this for each one of those. But let me do for one more here, for example. And the difference between layer group and layer is just that within a layer group, you can have sub-layers if you want to. So imagine that we kind of go ahead and select all these different layers. Then we can start creating the relationships between them, right? So I know that my service is going to use a model, so I can just go ahead and say, okay, this is this is an allowed dependency between these two. So you go ahead and kind of create those different things. So I do have one that I did more recently, and those things are already created. So so this is how you kind of, after you define those roles, define the layers, you kind of create the relationships between them. I also have, let's go jump into a more complete one, just to show the example. So this is how it ultimately would look, at least for this project, right? This is super powerful, because here I define what are my existing layers, right? And I define the relationship between those layers. And even here, for example, as part of my DAO, I have 3 sub-packages. And I really don't map them to anything. But what I'm saying is, I don't expect to have dependencies between them. Just the simple fact that I recognize that as a layer, and I don't define any relationships between them. It means that if you create dependencies, something's gonna tell you that it's something that you need to consider, right? So when I look at my list of dependencies here, I look at my cycles, and we saw that there was a cycle before. Now the dependency that is causing here, it's red because it's saying you never told me there was a dependency between my model and my web. So this becomes very easy to say, okay, so who's the infringing? It's because my owner object is depending on the crash controller, and that's not cool. I mean, that's not allowed. So if we can go into that, it's actually going to show me that I have a private crash controller here directly on my application. This is the offending piece, right? So so this is a very, very interesting way of kind of okay, now you understand what your layers should be, your modules should be, the dependencies and relationships between them, and going all the way, it helps you go all the way to the code to modify what is the conflicting there. This tool actually does a whole bunch more stuff. It actually allows you to make some pretend changes in the code to say, okay, what would happen if I made this change? And you can actually assign the change to a developer in your team. So the developer would be notified that this change needs to be made and all the tests needs to be performed and all the good stuff. So this kind of integrates well into the application. So let's say that now on my IDE for this project, right? So let's go to the project. And on my IDE, this project it's compiling just fine, right? But then if I hook into those new rules that I just created, so here's the SonarJ plugin for Eclipse, I can say that, okay, let's make this active. And based on that, whenever it's building my application, it's going to be checking for all those architecture definitions that I've just set up. Here, it found a bunch of stuff actually here, so let me do this. I think the problem is that I need to, let me see which one is using. It's using my pet clinic. Oops. It's using pet clinic sonograph. That's the one I have it here. Yeah, I excluded you too. So what's picking up here is that I didn't create any rules around my tests. So my tests are doing some funky stuff here that I didn't create a relationship that on my application. So, but if I look at this offending one, this is the one that it showed us before. You see how directly on my IDE I can have the visibility that I had in SonarJ. So whoever is kind of driving those definitions of the layers and relationships, they're the only they have to have the SonarJ application, the Sonograph application, and define all the good stuff there. But then your developers, they just need directly on the IDE, they have access to all that the information. So basically, they are not seeing why it's failing, but it's giving you a message here that basically this relationship between those two components are not allowed. Right, so if I went ahead and save that and recompile, that offending violation goes away. So that's kind of the pattern here. So the other thing I commented, so under the repository, we have these sub-packages, JDBC, JPA, and Spring data. if there's any new dependencies between those guys and any other parts of my system, this is also not going to be allowed. So this really, it's really kind of a nice way to kind of grow your application. And basically, if you create, it's not that you can no longer create new relationships between your points of the application, but it really becomes an exercise whenever you do to become visible to everyone. And this is what these tools kind of do for you. So any questions, comments on this? Yep.
Okay, in that example, you use only Java code, as I noticed. Often view layer is implemented with non-Java languages which relate to Java objects, such as JSP, JavaScript, etc. Does that static code analysis, any tool using that technique, guarantee that there are no cycle relationships between modules when they are not written only in Java?
Yeah, that becomes a little bit more difficult. And but for example, if it's in JSP in your example, I mean that would be picked up because it's looking at the bytecode of the compiled JSP and the Java. But if it's not Java, I don't know how well it can really depend on that specific object. At that point, it's going to be some other representation of the object. But I mean, I think it can be done, but it becomes a little bit more fuzzy at that point. All right. Okay, let's go back to slides here. All right, cool. So how do you make it all work? Number one is integrate this into your build system, right? Whenever you define this infrastructure, you need to have it integrated. You need to be always visible there. It needs to be part of your process. It's going to be important that it's always present, and it's not something that you just look before you go to live or you do the quarterly review or what have you. You need to have the owners, and who are the guys that are going to be defining those layers, defining those relationships, and whenever someone is trying to introduce new relationships, who do we go to kind of just have that conversation? And yeah, maybe it's good to go. Let's create this new arrow. Everyone is happy. And maintain and grow those set of rules. There's just not relationships. There's a bunch of other stuff that you can do. You can create rules, for example, that all my controllers need to inherit my base controller. Otherwise, I create an exception for it. At least, I mean, everything is visible. The new guy comes in the team. He doesn't necessarily get all this information right off the bat, and this will aid us to kind of have those conversations sooner whenever they are kind of coming across some of these issues. Define the different actions. So this is important. I mean, the way I've set up there, it's actually breaking the build whenever I offend the relationships. You can also lower that to be a warning or different kind of levels in your IDE, so you can still allow your developer to commit that. But it's going to be bugging them and showing that somewhere there. So you want to set the right severity level. There are certain things, certain offending things that are not a big deal. Others are something that you cannot just let it go. And just follow through, making sure that whenever you apply that, it's part of your process like anything else. Ideally, as you're committed to have your build, this will be a reason your build not to build. So it's as important as everything else. Again, not everything needs to be fixed. If you set up things that are lower level or certain categories that allow you to kind of revisit later, it's up to you to do. The way we kind of been trying to do more of keeping a pulse of overall number of warnings. If we have a certain number of warnings today, if we go over a certain threshold, then we do a sit together with everyone and we try to kind of resolve some of those. Just on an ongoing basis, those numbers don't get out of control. Fixed on high priority ones, I think that's given, and really monitor number of warnings, the code fragmentation, and your code coverage. There's all kind of interesting things that SCA can help you with. And yeah, so I recommend everyone just take the first step. If this is something that interests you, it's very easy to kind of become acquainted with some of these tools. Try to download a tool out there, play with it, see how your application looks today. For the most part, it's going to give you a lot of information just by that exercise, right? It's going to show you stuff that you've never seen before if you haven't played with some of these tools previously. Look at your current system, so see what are your problems, how many cycles do you have, what are the things that you can actually kind of split those up together. There was the talk before this, the one about the build times, the 10-second build times. it really kind of fits into this in the sense that the more you kind of compartmentalize your build and create the different jars and create libraries and things like that, you can really kind of minimize those dependencies and really decrease your build times based on those strategies. Then, whenever you adopt one of these tools, even if you don't do anything about your current system, the fact that you don't offend going forward, right? So your existing stuff, you say, okay, you're gonna grandfather all those problems. Going forward, let's define a certain strategy, and for new stuff, let's not offend. So let's stop the bleeding now, so we don't get worse. And that's usually not too hard to do. And then whenever you have that integrated in your build system, that becomes very visible. Okay, if this is new in certain parts of the system that is considered to be following the new strategy, that's your build system is going to pick up, and you're going to have a conversation. Then you start kind of going back to the code, going back to your old code, and say, okay, let's look at this cycle. Let's see how can we fix this cycle now, and go one at a time. Maybe every sprint you have, you put a couple stories there to break a couple cycles and things like that, and over time it really adds up. At the end, I mean, be smart about how you create your packages. I think that, for example, for that application, the way we created the layers, it was, I guess, the simplest way, the best way, the best case scenario, right? Everything, all the layers already compartmentalized. Whenever you go to a real application, it takes some time to retrofit an existing application to this, and then you need to get into actual code conventions for naming the files and all kinds of stuff. So, but the tool actually allows you to do all kinds of patching, matching against names and things like that. All right, I think that's what I had. And tomorrow we have also have a second talk. Just to, if you're interested, if you're doing multi-tenant, tomorrow I'm talking about the multi-tenant search, which is something that we apply directly at our product at Oracle. So just have some thoughts on that to share. All right, any questions?
Any questions?
I have a question about performance. So if I have a very huge code base, is the impact of such tools very big, or is it done in a sensible time so that I can use it in every build?
Yeah. What you define huge?
2 million lines of code.
Yeah. So that will probably add up a little bit of time. These things, for the most part, I mean, 100,000 lines will probably load in. The checks and all the checks will be probably about 20 seconds. So this, the 2 million will probably add up. But then at that point, you can really, if you start kind of breaking things apart, and you can do those in parallel, there's quite a bit of room to grow there. Any questions? Yep. Just one over there.
You've spoken today about modules. I would like to know your definition of components and how modules relate to components.
Yeah, and that kind of depends. I guess the answer is depends. I mean, your module can be a component, and I don't know if there's an official differentiation between those two. I guess it's how you modularize your product, so.
Anyone?
All right, and the book here.
Really good talk, thank you. I just wanted to say, if you want to learn how to build such a tool yourself and control the rules yourself, then stay in this room and watch my talk.
Right on. Cool, man. Thank you. Thanks, guys. Appreciate it.
Okay, thank you very much for your speech. Let's thank.
Thank you.